Greetings everyone. Welcome to today's video. For today's video, we'll be dealing with cyclicity and goes hand in hand with the last digit questions. But let's see how we perform in today's video. Cyclicity, I'm Clifford Wender. I train with the International Scholars Program. And without much further ado, let's jump into the video. So, what's cyclicity? Usually numbers in exponents, big exponents take a certain pattern, and we put focus on the last digit. This pattern is what we call the cycles of that number, and hence cyclicity. So it's often used in remainders and exponents questions. And I will say that in the practice question that we'll be doing later on after this slide. And the different cyclicities of numbers from 0 to 9. For instance, 0, 1, 5, and 6 are the cyclicity of 1, or they have a cyclicity of 1. Cyclicity of 4 and 9 is 2. Cyclicity of 2, 3, 7, and 8 is 4. Okay, let's pick a number here and see how these cyclicities come about. So let's take 2, simplest one. 2 to power 1. If you power it to 1, you have a 2. Focus on the last digit. 2 squared, this is 4. 2 cubed should give you 8. 2 to power 4 times 2, this is 16. So last digit of 6. Keep in mind that 2 to power 5, this is 32. Last digit of 2. 2 to power 6 is 64. 2 to power 7 equals to 128. Last digit is 248. So notice the pattern. 2486, that's 1. 248, if you take 2 to power 8, this will give you 256, I believe. Yeah, 2486 for the last digit. So it has a cycle of 4. Right? So this concept is really very important for high difficulty questions, since most test takers are faced with the questions that seem impossible to answer, and you don't have a calculator for sections such as problem solving questions in the quantitative reasoning section. Then we tend to be anxious and freak out because of the complexity of the question. Just looking at it causes that paranoia. So for that case, we have such kinds of tools that can help us in our arsenal to solve for these questions much easier. Yeah. And let's do a question and see how cyclicity questions can help, or this cyclicity concept can help in these questions. Okay, pause the video, give it a try, and then I'll jump in. What is the unit digit of 13 to power 35? This is a straightforward question. Once you have a question like this, just know it's cyclicity that's being tested. And I doubt if we can have such a question in the GMAT exam, but if it comes, then you're good to go. So the unit digit of 13 to power 35, we already know that from our previous slide, 3, which is the last digit for 13, has a cyclicity of 4. So 13 to power 35 will be, let's do this, 13 to power 35. It's like finding the last digit of 3 to power 35. And 3 has a cyclicity of 4. Let's try it and see. 3 to power 1, this is 3. 3 squared should be 9. 3 to power cubed, that should give you 27. 3 to power 4 should be a value ending in 1 because times 3, that's 21. So a value ending in 1. Then 3 to power 5, a value ending in 3 because of that 1. 3 to power 6, a value ending in 9. 3 to power 7, a value ending in 7 because of 3 times 9, which is 27. So the value should be ending in 7 and 3 to power 8. Yeah, I think I've gone far enough. As you can see, these are the cycles of 4. So for 3 to power 35, we check that power 35 and find the closest factor, not factor, but multiple of 4. Yes, it's 3 to power 36. We expect then 3 to power 36 to be a value ending in 1. Then if you go back then, 3 to power 35, we expect it to end in 7. You can also start from the lower part of it. 3 to power, say 3 to power 32, which is, sorry, 32, should be ending in 1. 3 to power 33, should end in 3. 3 to the power 34 should be ending in 9. And 3 to the power 35 should be ending in 7. So for both cases, it ends in 7. Right, so what's the units digit of 13 to the power 35? It's the same as the units digit of 3 to the power 35, which is 7. Answer choice D. Right. I hope you've paused the video, you've tried the question. Now I'll do it for us. 33 to the power 43. We'll start with 1. 33 to the power 43. So we already know that cyclicity of 3 from a previous question is 1397. 13971. Okay. And there is 3 to the power 1, 3 to the power 2, 3 to the power 3, 3 to the power 4. Then 3 to the power 43. The closest multiple of 4 will be 33 to the power 44, which will be or have a last digit of 7. That means then the previous term, which is 33 to the power 43, not the previous, but the 33 to the power 43 will be or have a last digit of 9. Okay, so remember we are using the last digit. You can use 33 to the power 43, or you can use just 3 to the power 43 and 3 to the power 44. Okay, now let's go to 43 to the power 33. The closest multiple of 4 will be 32. Looking at the exponent. So if 43 to the power 32, because which is the multiple of 4, ends in 7, then we expect 43 to the power 33 should end in 1397, so 1. Okay, so n equals to a value ending in 9 plus another value ending in 1. If you add this together, then you have a 9 plus 1, which is 10, and it should be a value ending in 0. Answer is A. As you can see, simplifies the question a lot. Yeah. For someone who doesn't know cyclicity, looking at the question, it might terrify the person or the test taker. So it's good for you to equip yourself with such skills. Now, let's go to the next question. We have, what is the remainder when 2 to the power 86 is divided by 9? Pause the video, give it a try, and then we'll do it together.
You are watching Success with Bob Mwiti Show, presented to you by the Kenya Airlift Program. The Kenya Airlift Program is an award-winning education financing scheme that helps bright Kenyan students to pursue graduate studies in North America, regardless of their financial background. You can find our programs by going to www.kenyaairliftprogram.com. The Kenya Airlift Program, empowering dreams.
Right. So what is the remainder when 2 to the power 86 is divided by 9? If you divide it by 9, then you have 2 over 9, which will have a remainder of 2. If you go to the next 2 to the power 2, which is 2 squared, divided by 9, which is 4 over 9, we'll have a remainder of 4. 2 to the power 3 divided by 9, which is 8 over 9, gives you a remainder of 8. Okay, let's see if we can have a cycle. 2 to the power 4 divided by 9, which is a 16 over 9, should give you a remainder of 7. 2 to the power 5 divided by 9, which is 32 divided by 9. 9, I believe, times 3, that's 27. So you have a remainder of 5. Okay, let's go on. 2 to the power 6 divided by 9, which is 64 divided by 9. The closest one is 63 because of I believe 7. So that gives us a remainder of 1. 2 to the power 7 divided by 9, which is 128 divided by 9, should give you a value by 9, goes in, I believe 128 divided by 9, goes in once because of 9, then 338. which gives you 4 because of that 6 and gives you a remainder of 2. 2 to the power 8, 9, which is 256 divided by 9. Equals to a remainder of 4. Yeah, hope you can see now the pattern here. 2, 4, 8, 7, 5, 1, 2, 4. So expect a 2, 4, 8, 7, 5, 1 cycle for the remainders, which is a bit long, not compared to the other cycles. But yeah, it works for this case. Yeah, it works for this case. And so 2 to the power 86 divided by 9 gives us a remainder of what? We had a 2, 4, 8, 7. So 3 isn't there, so we can eliminate that. There's no need for actually eliminating. We can just find the multiples of the exponent. So every how many? We have a cyclicity of 1, 2, 3, 4, 5, 6. So for every 6, we have a cyclicity or the last digit or a remainder, not a last digit, but the remainder of 1. Let's go to H4. H4 is divisible by 2 because of H plus 4, that's 12. And H4 is a multiple of 2. So 2 to the power 84 gives us a remainder of 1. Okay, so 2 to the power 85 gives us a remainder of. Next is 2. And 2 to the power 86 gives us a remainder of. Next one is 4. And therefore, the remainder is 4 when 2 to the power 86 is divided by 9. I hope that's clear. Let's go on to the next question. Right, so what is the remainder if 7 to the power 384, that's a huge number, is divided by 5? Now, when it comes to cyclicity and divisibility for 5, 10, and 2, you look at the last digit. So that's a hint. Give the question a try, pause the video, and then jump in. Okay, so since we know that a number is divisible by 5 if it ends in a 5 or a 0, if it's an integer, of course, and since we're dealing with integers here, so expect if the value ends in 5 or a 0, then it's divisible by 4. Not 4, but 5, sorry. So for this case, let's look at the last digit. Yeah. So if you're told about divisibility, remainders 5, 10, or 2, then you look at the cyclicity of the number or the last digit of that number. So the cyclicity of 7 is 4. Let's look at it. 7 to the power 1 should be 7. 7 squared, which is 49. 7 cubed, 9 times 7, that should be a number ending in 3. 7 to the power 4, that is a number ending in 1 because of 21. Then 7 to the power 5. The moment you realize we have a 1 here, then expect the cycle to begin again. 7, 7 to the power 6, yeah, and so on, so forth. Okay, so we have a 7, 9, 3, 1 for multiples of 4. So 7 to the power multiple of 4 should give you a number ending in 1. So 384, is it divisible by 4? Let's see. 384, the last two digits are we evaluate that. 84 is divisible by 4. So 384 is divisible by 4. One thing you need to realize also, as you look at these questions, you're being tested very many things at once. Their divisibility, the last digit, cyclicity, remainders, all this are being tested in just one question. So 384 is divisible by 4. That means 7 power 384 should be a value ending in, or should give a value ending in 1, which is answer choice B. So the remainder of 7 to the power 384 when so the remainder of 7, if 7 to the power 384 is divided by 5, will be, we expect then, if it ends in 1, the closest or the smallest, which is closest to this are digits that you'll find here, ending in 1 will be another digit, which is divisible, which is ends in a 0. Yes, it's the one ending in 5 will be a bit further. It has a space of 4 then, and it's actually bigger. We expect a smaller value. In that case, the remainder will be 1. Okay, let's give an example. So if you have a value like 41, what's the remainder when divided by 5? The remainder is 1 because of that 40. You can do the same for 51 divided by 5. The remainder is 1. 61 divided by 5. The remainder is still 1. Yeah. So that also, whatever value you have here ending in 1 divided by 5, the remainder will be 1. Right, guys. I hope you've enjoyed the session. I hope you found insightful things from the video. Once again, I'm Clifford Winder. I train at the International Scholars Program, and have a lovely day. Till the next video. Bye-bye.